Hello there. In class we talked about circumcenter, and it has this rather remarkable property that it is the point of concurrency of the perpendicular bisectors. So in this video we're going to go over why the three perpendicular bisectors of any triangle all have to intersect at the same point, because that's a rather remarkable property. Usually you get three lines and they don't all intersect at the same point, and you have some sort of small triangle. So I'm going to construct two perpendicular bisectors first for these two sides. Of course I'm eyeballing this, but we'll be forgiving. We'll call this point X, and we can call this point Y. And what we're going to want to show is that their intersection down here, which we'll call O, because usually O is reserved for the center of the circle, what we're going to want to show is that O is equidistant away from all of these points to begin with. That'll be useful in showing that O is on the perpendicular bisector of the next line too. So I'm just going to sketch in those lines. Whoa, that is not a line, not a good line. Maybe we should have paused it. Alright, sketch in that line, sketch in that line, sketch in that line. What we're going to want to try to show is that all of these green lines are congruent to each other. And we're going to do that with triangles. So we have a triangle here and a triangle here, and we're going to show that those two triangles are congruent to each other. And we get that by this. Those two lines are congruent by definition of midpoint. That's at a 90-degree angle, so those angles are congruent, and this line is shared between them. So you get those triangles by side angle side. Boom, 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 boom. Okay, so we got those two triangles. And that gives us the green lines AO and BO. How many parts of congruent triangles are congruent? Okay, so moving over to the other side, we're going to have this triangle and this triangle. So once again, we have midpoint getting us BY and CY. Got 90-degree angle, and YO is shared between the two of them, so we got triangle BYO is congruent to triangle CYO. And that's going to get us the green parts too. Okay, so over here, if AO is congruent to BO and BO is congruent to CO, then AO is congruent to CO. And we get that by substitution, or more formally called the transitive property. And this would actually be the transitive property. Alright, so that gives us AO and CO. Okay, so that's actually enough to show that point O is equidistant from all these other points. O would then be called the circumcenter. And it's a point that's equidistant away from each of the three original points of the circle, or the triangle. So there's actually a big circle that encompasses all of these points that's centered at O. However, that's not what we wanted to show in this video, because in this one, we just took the perpendicular bisectors of A, B, and BC. What we want to show is that the perpendicular bisector of AC must also go through O. And I'm going to do that by drawing in this blue line here, and I'm going to connect a point O to a point P, which we'll define as being perpendicular. So I get to choose one of these things. Clearly there's some place along this line where I can create an altitude to O, so I'm going to call that point P. What we're going to show is that not only is that perpendicular, it's also going to wind up being a bisector. If the sketch over on the right is getting a little bit too busy, I can redo it over here. There's A, there's B, there's O. We're going to call this point P. It's perpendicular, and we know that AO is congruent to BO. So what I get is that these two lines are congruent, these two lines are congruent. I have the 90-degree angle in there because of how I selected it, and that's on both sides. And this side here, PO, that's shared between the two of them. And it may look like this is angle side-side, but the trick is that the angle was a 90-degree angle, so this is actually the hypotenuse leg congruence theorem. And then we're able to get that those other parts there, AP has to be congruent to BP. The corresponding parts of congruent triangles are congruent. So we were able to establish that in this big thing over here, that point P, this means is that P is the midpoint of AB. So we got another perpendicular bisector. And is that newsbreak music coming on? This proves concurrency. These were perpendicular bisectors, and this light blue line, we selected it to be perpendicular. It also wound up being a bisector. It has to go through O. So all of those perpendicular bisectors intersect at the same point O. And we'll finish that one up. And we got music going on. Oh yeah. PO is perpendicular to AC. And then those were also perpendicular bisectors. All those perpendicular bisectors intersect at O. They're concurrent. Character and Scholarship for Life.